In this problem, we're asked to replace the two forces acting on the frame with an equivalent force acting at point A. Specifically, we'll determine the magnitude of the equivalent force and the location of point A. Pause the tape and think about an approach to solving this problem, and then we'll come back and go through it. Okay, so the first part of this problem is that we need to use the principle of transmissibility to slide these force vectors along their line of action. And this is appropriate for problems where we're interested in external forces, statics problems. Okay, so principle of transmissibility. That's our first step. So we're going to slide the forces along their lines of action. And that enables us to use the parallelogram law to add them. And in doing that, we have to use the law of cosines and the law of sines. Okay, and if you're a bit rusty on law of cosines, law of sines, check the appendix in the back of your statics book. Miriam's book in particular has a lot of good information back there. Okay, and then once we have done that, so let's look at the law of the parallelogram law. So parallel to the 800-pound force, parallel to the 900-pound force, that gives us a resultant force that acts right here. I'm going to call that R. Okay, and then that parallelogram can be broken into triangles, which is where the law of cosines and the law of sines comes in. So let's look at the top triangle. So here's the top triangle, where this is our 800-pound force and our 900-pound force is on the top there, and this is the equivalent force that we're looking for, R. And we can use the law of cosines here if we knew one of the angles. So we need to determine an angle, and we can do that because we know the slope of this line is 1/2. So that enables us to calculate this angle. I'm going to just call it alpha here. So the tangent of alpha is equal to 2/1, which gives alpha equal to 63.4 degrees. Okay, now the law of cosines gives us r squared is equal to 800 squared plus 900 squared minus 2 times 800 times 900 times the cosine 63.4 degrees. So R turns out to be equal to 898 pounds. Okay, that's the resultant force, and now we need to get its direction, and we can define its direction through this angle from the vertical, angle beta, and we can find that angle using the law of sines. So the sine of beta over the sine of 63.4, that ratio has to be equal to the ratio of the opposite edge lengths. So we have beta, so it's 900 divided by 898. So this gives beta is equal to 63.6 degrees. And then what we do is use the principle of transmissibility again to slide this resultant or the equivalent force vector R up to point A. And then what remains is to calculate the distance from point A to the left edge. That's the distance x. So now we need a little right triangle where the top leg is x and the bottom leg is determined from the size of the frame. So we know that the slope of the line of action of the 400-pound force is 1/2, and the width of the frame is 6 feet. So that line of action is going to go up 3 feet to this point. And this is the triangle above that we're looking for. So that's 2 feet there. So that says that that side is 2 feet. And this is the angle beta that we just calculated. So then we can say that the tangent of beta, which is 63.6 degrees, is equal to x over 2. And then we can calculate x to be 4.03 feet. So we have the position of the force, we have the direction of the force, and we have the magnitude of the force, and that's it. I hope this was enlightening. Thank you.